Hi, this is a Group 24, also known as Group WALLE, Project WALLE, and we have come up with 4 different things that we thought were pretty cool in terms of engineering. First thing is we have a PID control, which our teammate Isaacs will explain about how the QRD sensors help turning of the robot.
All right, one cool aspect of our robot is our use of PID control for our line following. PID stands for proportional, integral, and derivative control. The proportional aspect makes it so the robot turns when it sees the line, and the further away it is from the line, the more it's going to turn. Problem with this is that it sometimes overshoots the line or it oscillates. The derivative aspect makes it not oscillate, and the integral aspect makes it so it doesn't drift on the line. We use this to make make the line following smooth and good.
We did use 5 QRDs instead of 3, like most teams, which will also be explained in that section.
One problem that we had with our robot was that the 3 sensors was causing it to be kind of out of control. We decided to go up to 5 QRD sensors for the line following it to make it so that it would have more smooth adjustments on the line following instead of jerky and really jittery adjustments.
We used IR sensor covers to make sure no IR sensing came from any other objects to protect our sensors that we used for the canyon section. And a lot of their teams did this, but this was also pretty cool. We used a bumper to get the ball, so that way we did not run our wires and actual machine into the ball dispenser.
Some of the design decisions that we made were we did a 2-layer design, so that's how we sandwiched our motors in. We don't have any adhesive or anything keeping them in place. It's just the 2 layers are pretty tightly positioned together. And then another design decision that we made was we used 1 servo on our entire design. So we have the same servo for our ball catcher and for our laser, and that just eliminates excess hardware and doesn't take up as much space. And then another design decision that we made was that we used IR sensors instead of sonar because they're digital, and that's why on our robot we have the little T shape or the little arms extending on the side, just so our IR sensors could get out a little bit further so they could detect the wall better.
Okay, some things that we thought would be useful to change would maybe be designing the chassis from the beginning to fit all of our parts. And rather than just using like a proto board to do that, we would maybe 3D print it so that it has some things in place already from the beginning. Something else that we wanted to do along with designing the chassis like that would be mount everything properly. That was an issue that we ran into with all of our parts just kind of floating around. And then we would also create some custom PCBs rather than doing the wiring ourselves, because that got kind of messy as well. And then also something that we were thinking would be useful would be to change the pick, like the extensions. We would create some sort of extension so that we could, our pick is kind of deep within our robot and all the wiring, so we would go through and make some sort of extension so that we could easily access all of the pins. And then another thing we would do is put our motors at max speed from the beginning so we could just kind of bypass the jitter range of the motors, because we were having that issue in the beginning. And then we would also 3D model and print more parts so that we could better manage the wires and the hardware.
Get that sandwich.